Hi folks, this is the 14th problem of the DSA series, so let's get started. It says permutation in a string. You are given two strings s1 and s2. Return true if s2 contains a permutation of s1 or false otherwise. That means if a permutation of s1 exists as a substring of s2, then return true. Both string only contain lowercase letters. Okay, what does it mean? So what is permutation? So ABC can have multiple permutations. ABC, BAC, CBA, CAB, etc. etc. Right? So permutation is nothing but different arrangements of the letters, right? So we gotta find if this substring is present in this S2 string. Is it? Yes, it is CAB. A permutation of ABC. That is a rearrangement is present. That is why returned true. Understood? Here, see again, is S1 present in S2? By present, I mean if any permutation of S1 is present in S2. No, it doesn't. We have CAAB where A came twice, right? So it doesn't. However, if we had this, then it could have returned true. However, if we don't, hence it returned false. So I hope you understand what let's call it string permutation, and let's do it. I'll show you two ways to do it. First, a simpler way, and then a little better way, right? Both are simple actually, but yeah. So this is the simpler way, which has the space and time complexity of, as we go ahead, I'll explain you. Okay, so this will take s1 string and s2 string. First and foremost, let's check if s1 dot length exceeds s2 dot length, then we don't have to do anything, simply return false, because if s1's length exceeds s2's length, s1 cannot be s2's substring, as simple as that. Now what we'll do, now this is the approach that will take. Sliding window is the approach that will take. This is substring ABC. First we'll take this window. Is ABC present here? No. Then move one towards right. Is ABC present here? No. Then move one towards right. Then again, is ABC present here? Then move one towards right, and so on, right? This is what we'll do on, and each step will calculate the frequency of characters that are coming, right? First of all, we'll calculate the frequency of ABC in an object, or you can say in a map A1, B1, C1. Then we'll calculate this LEC, right? Then we'll calculate this wherever these two matches, the frequency of these two matches, there we have found the match. Okay, so let's do it. So we'll have let frequency is equals to this empty object. Now we can say for let car of s1, right? And then simply say frequency car is equals to, if let's say A came twice, then add 1 in A. Let's say we had this, then we can on the second iteration, when coming on the second index, we'll simply add 1, right? However, what if A is not present, or this character is not present as key? Then simply make it 0 if it is undefined. Okay, so this gave us our first object, right, which contains frequency of each and every characters from this s1. Now let's map over it. For let I is equals to 0, I is smaller than, I guess we can take length of this only till this point, right? Only till this point we won't want till here. So we can do s2 dot length minus s1 dot length I plus plus. Now we can simply say substring is equals to s2 dot substring. Yeah, there is substring method. We'll take each substring, first this, then this, then this, so on, like moving one step towards right every time. Substring is equals to I plus s1 dot length. This is the substring. Now we can map over the substring for and in mapping over. Okay, so we can map simply like this. We can say substring. We also got a let substring frequency. Substring, like what's the frequency of characters in this substring? We gotta know that, right? Substring frec is equals to this. Then we'll compare these two objects, this and this. If these are equal, then awesome, go ahead, return true. Right, substring frequency. Instead of this, write this, it will give us substring frequency. Now let's simply compare. For that I can write another, like a different function, like compare maps. That's it. If compare maps will get frequency as well as substring frequency. If it returns true, simply return true. If not, then no worries, simply return false. That means the permutation is not found. Okay, first let's see if this is working or not. Only then I'll tell you space and time complexity. What's the name? String permutation. So yeah, let's call this s1 s2. And let's call it here. And then what's the other example? This one. Const s1, const s2, const s1, const s2. Now let's comment this and see what comes. Note 014 permutation in string logics. Awesome. Okay, we are not giving s1 and s2 here, s1 and s2 here. Okay, compare maps is not defined. Oh, we gotta write this, no? Here we are comparing these two objects. So let's write it quickly. Compare maps, it will get two maps. Let's call them map1 and map2. By map I simply mean objects and nothing more. Then we can say const key1 is equals to, instead of key1, keys1, object dot keys map1. It will give us the keys for the first map, and this will give us the keys for second map. Now we can first simply compare the length of these keys, and if they are equal. Actually, if they are not equal, then return false. However, if they are equal, then we have to proceed further. We have to check each and every key value pair. So we'll say for let key of, we can say keys 1. We could have said keys 2 as well. There is no problem in there. But yeah, we have set keys 1, and now we can check if map 1 key is equals to map 2 key. If these are equal, actually instead of equal we can say if these are not actually equal, these are not for a particular key, if the values are not same or undefined or whatever, simply return false if these are not equal. However, if these are equal, the loop has ended, simply return true. Now see if things are working. Yep, it returned true for this. Now let's check this. It should return false for this. Yeah, it's returned false for this. It is working. Now let's get into space complexity. What is space complexity? Space complexity is O of 1, because why? Because it says both strings only contain lowercase letters. Although we are making two objects or two maps, how many keys they have? Max 26, right? Because we have 26 alphabets in English lowercase letters, right? And that is a constant. That is why space complexity is O of 1. O of 1. Now let's get into time complexity. What is time complexity? So here we have two loops going. One is this outer loop, another is this inner loop. This loop is the substrings of the length of S1, right? And this is of length S2, right? Like, it doesn't matter if it's very small. So yeah, this is S2 length, this is S1 length. So we have two loops going on, n into m, where n is the length of string S2, m is the length of string S1. So this is the time complexity. Now we can make it a little better we can do it with time complexity O of n. Now I'll show you how we can do it using O of n, right? Let me just do it right. Function string permutation final. It will again take S1 and S2. Let's just comment this. Okay. Now here what we're doing wrong here, not actually wrong, but things could be optimized in this. So we were first taking this, no worries, then taking this, moving one step ahead in every iteration. However, we are iterating over all of these three, to get the number of times in which each of these characters are occurring, right? So yeah, we are making a map E1 C1 A1, right? Then for this C1 A2, like this. So we are mapping again and again. This we don't have to do. So what we can do instead, we can simply first come here, LEC, okay. Here we can iterate, okay, this is one. Then in the next sliding window, when we slide for one time, we can simply remove the frequency for which L came. So then E1 C1 will remain as it is, L1 will be removed, and A1 will be taken into account. Then move one step again ahead, again remove E and do A equals to 2. So we don't have to iterate over all of this again and again. We can, as we move ahead, we can include the right side element and exclude the left side element that we are moving away from, right? So that is what we can do. So in this manner we can get to the result in one iteration through S2. That's it, and hence we get O of n. Time complexity. Space complexity will remain O of 1 as here, right? Yeah, so now let me show you how to do it. It is easy, just bear with me. So let me see if the shit is recording. Okay, it is recording. Okay. Okay, first we can do it like this, the same thing. If S1's length is greater, then simply return false. Now we'll have two maps. Let's call them map 1, which will represent the string s1, right? Then map 2, which will represent the string s2, right? This map 1 will not change because this string is as it is. However, this map 2 will change as we slide our window towards right. Here we have lec in our sliding window, then we have eca in our sliding window. So as we move right, elements will come and go, or the values will change of key for keys in map 2, but map 1 will remain as it is. And then we'll compare every time we slide. If in any after any slide that shit matches, we'll say yeah, hooray, we'll return true. Yeah, so that is what we'll do. So first let's make map 1 and map 2. For let I equals to 0, I is smaller than s1 dot length, I plus y s1 dot length, because yeah, we got to calculate permutations of s1 only. So length will be s1 for both. So here we can say the same thing that we did here. Okay, so we can say frequency, not frequency, simply map 1. Here we can say s1 I, this is the character. Now s1 I for map 1, because map 1 represents s1, and then for map 2 we can simply do map 2 represents s2. So here this is the map 2's frequency till first 3 characters, right? Because s1 is also 3 characters. So yeah, this is it. Now we'll move and change the map 2 accordingly. Now first let me show you the matches. Like what if we have the matches here? Like we could have find CAB or ABC here as well. So we'll check the matches. So in order to check the matches, so what do I mean by matches? Nothing, no. So for this we have A1 B1 C1. For this, if we have A1 B1 C1, then we have like 3 matches. Like if this is AAB, then we have A2 B1, right? If this would be AAB, then we will have A2 B1 in case of AAB, right? So we have 2 matches, like for A and for B. If here we also found A2 B1, then yeah, 2 matches, then awesome, return true. So like this, we will check the key value pair, right? If we could have like triple A here, so we have A3. So this is here we could also have A3. So we have like one match is equals to 1. If we have like 1, this key value pair has matched, then awesome, right? And I hope you understand what match is. Very simple concept, nothing much. So we'll check if shit matches. So for that, what we gotta do is we have a for loop over map. So let key of map 1, because yeah, we want permutations of this s1, and map 1 represents s1, and we can say if map 1 key, let's first call matches is equals to 0. Right now, if map 1 key is equals to map 2 key, if map 2 key present and the values are equal, right? That is the case, then do what? Then simply increment the matches by 1. Okay, so for ABC, matches should be 3 if it matches, right? Now we'll check if so matches is 3, if matches is equals to object dot keys map 1 dot length. If this is the thing, then simply return true, as no worries. right? If this is the thing, that is the match happened in the first step only, in the first sliding window only, then it's awesome. In here then it's awesome, else we'll proceed and move to the next combination, which is this, and then next, and then next. Okay, so it happened here, then awesome. If not, then simply do for let I is equals to, actually we don't have to start from 0, so I'll say right is equals to, so since we already compared these initial three, we got to start from here, so right is equals to s1 dot length, s1 dot length, we got to do right plus plus, but till when right should be smaller than s2 dot length. Just yeah, okay, right is equal to s2 dot length. Okay, now what we'll do is, the right is incremented every time, we'll check the new right, so we'll say const right car is equals to s2 right. Now we'll update const map to right car. If it exists, then again simply the same thing, we don't have to have const here because map 2 is already declared, right? If it exists, increment it by 1, if it doesn't, simply make it 0. Okay, do this. Now we'll check, so this is the little tricky part, so yeah, watch carefully. Here what we'll do, we'll simply check if map to right car is now equals to map 1 right car. If that is, if values now after this increment, if the values now match, that means we can increment the matches by 1, right? However, there can be another case, if let's say values were matching previously, now after increment they are not, we have to decrement the matches by 1, right? What do I mean? If let's say a let's say we can get x, let's say a was here, so the values were matching LAC, so map was 2 here because a and c are matching, a and c are matching. However, when we, so it's let's make it a and make it z something. Okay, so now values were matching, so map was like 2 because a and c both were matching. Now if we move here, the a won't match, so the map is reduced, so sorry, not map, matches are reduced, map matches is 1 now instead of 2, right? So this can happen as well. So else if map 2, we got to increment 1 here in order to get to this map 2, now in that case we got to do matches minus minus, right? So this is little bit tricky, but yeah, so this is what, how it happens. Now we got to do the same thing for the left side, but now we got to do the same thing for the left side, right? So instead of right car, let's call it left car. Let's say left is equals to 0 initially, right? Left is just starting from 0, so left car is equals to this, left car is equals to, just copy this map to left car. Okay, left car, if left car was like here, again the same thing, we got to decrement this because we will remove the left car, right? we'll remove the left curves. We got a decrement, we are moving from left, right? So we got a decrement here, right? Because you understood, no? We are removing, we are moving to this, sorry, we are moving to this, right? That's why we have to remove this a, right? So we'll say -1. Now if after doing -1 shit matches, do matches 1 1. If it doesn't, right, like there is difference of 1, then simply do match minus minus. Let me just copy paste this. Right, now it's very easy. Now we simply have to do this. We'll simply check the matches. If matches is equals to this length, if yeah it is, then return true. If it's not, then yeah, it will simply continue the loop. And also one more thing, we got a right is being incremented by this loop automatically. However, we got to increment the left as well. We got to move from left as well, from this to this, right? So we'll do left plus plus, right? Then the loop will continue, and here in the end return false. If nothing matches, the loop continues, came to the end, and here we turn false. Now let's see if it is working. Console log, we'll again give here s1 s2. What is s1 s2? Okay, a b c, it should return true and didn't fuck up. Awesome. Map 1 is not iterable. Key in, sorry, key in, because this is an object, right? Okay, so it returned true for this. Now let's do it for this below one, and it should return false because we don't have ABC. Permutation of ABC, I can't see. Or is it? No, there isn't. It is written. So yep, it is working. Now the again space complexity is O of 1 because there are 26 characters in English alphabets, and we have like these two, 26 max 52. So yeah, it's O of 1. Time complexity here is O of n, since we are iterating over the length of the string s2 for one time, right? So the time complexity is O of n. Let me write it. Time complexity O of n, space complexity again O of 1. Okay, so yeah, that's all from my side. I'll push this. Thanks for watching, guys.